Let's integrate the function 2 to the t dt from 3 to 9. Well, I need to know the formulas of integration of exponential functions. I remember that integral of e to the x is the best one. It just gives me e to the x, and of course plus c. But what is happening with the exponential function with any base a? Integral of a to the x dx equals. Maybe you remember first the derivative of a to the x. If you just said no, that's okay. Let's review both. The derivative of a to the x will be copy, just like with e to the x, and then multiply by the natural log of the base. And that is why e to the x gives you e to the x, because ln of e is what? 1, exactly. So if I want to undo the differentiation, the result will be copy a to the x and divide by the natural log of the base plus c. And this is the formula I'll be using right now. The result of this integral will be copy 2 to the t and divide by the natural log of the base 2. Instead of plus c, I will have a bar from 3 to 9. And answer follows right away. 2 to the 9 minus 2 to the 3 all over natural log of 2. And that is the final answer. Remember, you cannot collect 2 to the 9 minus 2 to the 3 because of how exponential functions work. So that is a good answer to give. Maybe you can factor out 2 to the cube if you want, but that's a not very necessary step. What I wanted to show instead is if you plot the function inside of the integral called integrand, in this case is 2 to the t, this is how it looks. Well, they ask us to find the area from 3 to 9. It's gonna be this nice, beautiful area. As you can see, it's positive, it's above x-axis. And the farther we go, the faster it grows. So if they ask us to integrate from 3 to say 100, the number will be huge. Actually, I never mentioned how big this number is. Did you try to find out? It looks not very big, but exponential functions grow very fast, basically exponentially. So it is a large number, 727.12. Exact answer is always better, so the one in the green box is a more preferable answer. Good job for working hard.